So the question is the molecule sf4 polar or nonpolar? So the Lewis structure of a molecule indicates the polarity of the molecule. So when the central atom has an odd number of lone pairs, the molecule is generally polar. But if the central atom of a molecule has an even number of lone pairs, you have to decide on the VSEPR diagram, the VSEPR structure, so the shape of the molecule, before making a decision. So then sulfur has one lone pair, which means the molecule is polar. So the forces of the lone pair force the molecular geometry of SF4. I'll draw it in a minute to make that more clear. So because of the lone pair, two SF bonds are pointing away from each other, so those dipoles cancel each other out. But then the other two SF bonds are pointing downwards and do not cancel each other out, which is what makes it polar. So if we're going to draw that out, so sulfur is obviously our central atom. So it may be tempting to draw it like this and make it tetrahedral, but then you didn't take into account the extra lone pair of sulfur, so this is wrong. So what really happens is sulfur, we're going to draw a lone pair up the top. So this lone pair, you can draw it like this, takes up some space. So what it does, so we have the two fluorines that sit horizontally, so they're fine. But the two other fluorine bonds, SF bonds, are getting pushed down because the lone pair is taking up so much space. So then the dipole moment, we're going to push, the electrons are going to push to the more electronegative atom, so all four fluorines in this case. So the dipole moment of these two fluorines cancel each other out because one's going one way, one's going the other, it's even. These two, on the other hand, do not cancel each other out. So then you can determine the molecule is polar.